So in today's video, we'll be writing a function that will fill our structure from an array. So I'm going to show you some code. So here we can see the structure image section header, and it contains these members. If you want to write each and every field with this value, it's gonna take so much time. So we will read from an array and we will fill automatically these members from that array. So the first 8 bytes of those array goes to this name, and next 4 bytes will go to virtual size, and next 4 bytes goes to virtual address. So we'll be automatically filling up this structure from the array. So that's what we are going to write the function. So these functions are the core of the upcoming videos. So let's declare a structure. So let's say marks. Now I'm going to type English. So let English U32 and social U32, Hindi U32. So I'm declaring the members of the structure max U32. So we have 4 members. These belong to the marks: English, social, Hindi and max, and we need to declare we are dealing with the C type structures. So that means the data type inside of these members should be of C valid data types, representation of C. So we are going to represent this structure as a C, and let's also derive some attributes: debug and default. So default is the main one, because by default, if you specify the default, it will be getting an object with all the values as 0. So that is what the default trait does. And clone, in case if you want to copy. Now let's go and create a mark list. So let's say let mute m1 is equals to marks, and here we need to specify all the marks: English, so here you can see all of those marks. And we can print these as well. So these are the values. Suppose I want to fill the structure this one. So imagine declaring like this. You need to say image section header, open brace, name is equals to this array, virtual size this one, virtual address this one, etc. So that is very tedious one. We can also say default. So this will take the all values as 0. So we can see all of this as 0. Now I have an array. So let's say mark list of array of type I32, and we have 4 subjects, right? So let's give the marks 40, 50, 60, 70. Okay, I32 comma 4, right? Okay, so I want to fill this mark list into this structure. So I if I want to say marks of English is equals to mark list of 5. So it will be very tough task to fill the elements with this in this structure. So that's why we are going to write the function, that is pub function fill structure from array. So in this, what we are going to do is we are going to take 2 values, that is the this structure object, and the next one is a reference to an array. So we are going to use the generics because this can be i32 or i8 as well. And let's declare parameters base, and we want to get the mutable reference to this object because we want to overwrite the default values to these 40, 50, 60, 70. So that's why we want the mutable reference, mutable t. And the next one is the array. So u is ampersand, let's say r is equals to ampersand array of type u. And first we are going to write enter this entire thing in unsafe because we are going to use the Windows API write process memory for this one. So basically what we are going to do is we are going to fetch the starting address of this mark list and the starting address of m1, that are base addresses, and we are going to write entire this memory into this object address. So when we access this m1.english, we will get the values. So values will be automatically written into this memory address. So we are going to first compare if std size of t. So we are going to first compare the size of structure and array whether they are equal or not. Not is equals to std size of val u. Then we are going to print, or we can directly panic sizes are not equal, and if the sizes are equal, we want to write the contents at this address to this one. So let's go and use write process memory, and we can use get current process to get the current process handle. And second one is the base address we want to write, so that is this one, base as star mute t as star mute c void. So we are converting this into a raw pointer. And the next one is the buffer, so that is this one, array as constant u as constant c void. So we are converting this into raw pointer, and how much we want to write, that is array dot length. So this should be fine. We can say underscore, so that we don't need to worry about the type. This function takes 5 parameters, but 4 were given. So handle and the base. Okay, last one is we don't want to care about how many bytes we have written, so we can pass null mutable pointer, and now we are good to go. So we have written the content, and we can actually care about this. Let mute bytes written is equals to 0, and we can pass this one as a mutable reference here, ampersand mute bytes written. And now you can return this number of bytes written, so that you will get some idea if anything goes wrong. this one is usize, so return type is usize. Now our function is ready. So all we want to do is we want to fill this structure. So fill structure from an array and ampersand mute m1. Since we are writing the contents, we need mutable reference, and this one is ampersand mark list, and we are good to go. So let's copy this and paste here. So we are printing before filling the structure and after filling the structure. So let's go and run this, and here we can see, oh, we got only the first value, so something gone wrong. Let's go and solve this. Okay, we are writing only 4 bytes, so why is that? Oh, sorry, it's we are my bad. Here we need to remove this array length, and we need to specify the size of array, sorry, the memory size of array, not the length, because length is only 4, so that's why we are writing only 4 bytes. So std mem size of value of array. Now we will be writing an entire array. So let's run this, and we can see all of the contents have been filled in the structure. So the 16 bytes, so I32 4 bytes each one, 4 into 4 16, so 16 bytes were written into the structure. So this is how we fill the structure from an array in Rust. So don't skip this video, this is very important, and also the next video. These are the like very important for the future videos.